Okay, yeah. Hi guys, good evening. Welcome to Cracku. I think we are live now. You are able to hear me. Just let me know if you are able to hear me properly. You can put it in chat. So yeah. Hi, good evening. Welcome to Cracku. Today we'll be doing a session on probability. I hope that you are following the live streams. One thing I would like to request all of you that if you like our streams and if you have fellow friends who are also preparing for IIM Bangalore UG entrance exam, you can share our streams. Our streams are free, and we are conducting a stream every day from 8 to 9:30 in the evening, and we are covering all the important topics. So I would request all of you that if you have friends who are also preparing, you can share our streams. So yeah, we'll be studying about probability today. This is something I hope that you would have studied in your school also, but uh, on an entrance level, the level is a little higher. The questions are asked on a slightly difficult side. So we'll be covering all the important things that are there in probability. Next, yeah. So this is the schedule we are following. Yesterday you would have studied quadrilateral. The day before that we conducted a webinar. So my friend Bala conducted the webinar, and he would have answered all your doubts there. Also before that, IIM Bangalore also conducted a webinar to answer all your queries. Further, today we'll be studying probability. The next schedule as follows: that there is a DI basics, that is data interpretation. We are having a good uh, probability that IIM Bangalore is going to test your data interpretation by giving you some sort of sets. So we'll be covering that also. Then you have matrices and determinants. We will be conducting two different sessions for that. That is something you would have covered in your 11th or 12th only, but we'll be again revising them, and we'll be trying to see what kind of questions they can be IIM Bangalore can ask. Then we have two sessions on calculus. So we have all the sessions lined up, and we are preparing the sessions according to what IIM Bangalore can ask. So I would suggest you all to please attend the sessions every day, and make your notes appear for the playlist. That is something we are giving free of cost. You can go to Cracku. You can go to Google and search Cracku IIM Bangalore UG playlist, and you'll get the full course link. All the videos are there, which we have thought a lot about what can IIM Bangalore ask, and we have put all the videos in a particular sequence. You can go through the videos. You can cover all your basics. Next, we have this is something very important. Basically, the exam is going to be of 2 hours, and for a lot of you, you might not be a lot of accustomed to sitting for 2 hours and fully focusing on an entrance exam. That is why we have 5 free mocks based on the pattern that IIM Bangalore has suggested. All the mocks are free. You can appear for the mocks at your pace, at your time. Go to Google, search Cracku IIM Bangalore UG mock test. You can use this phrase, and you'll get the first link for our mocks. The mocks are very good. They're taken by a lot of people, a lot of students right now. I would highly suggest you guys, if you have not appeared so far, please appear. See where do you stand. You'll get to know a lot. And also, considering the exam is in next month, you also don't have a lot of time. So appear for the mocks as soon as possible and see where do you stand and try to improve yourself. Next, we have a WhatsApp group. See, basically, this is the first time IIM Bangalore is conducting an entrance exam, and that too for a new course. So there are chances that there are some important notifications, but you might be unsure where do you find all the notifications. So that's why we created this WhatsApp group. You can join this. The link is in the description. Once you join, you will get all the important updates, all the important notifications that IIM Bangalore releases, and all other important things within that group only. So you can join, and then you can stay free. You will have all the things at one place. With that, we'll start our session. See, before we start probability, we'll cover up a few basic terms. First, we have an experiment. Experiment is nothing but when you do an action but you don't know what can be the possible outcome. For example, rolling a dice. A dice can have 6 faces and they are numbered from 1 to 6. If you roll a dice but you don't know what would be the outcome, that would be called an experiment. It can be anything. If you toss a coin, that can also be an experiment. So any action for which you don't know the final outcome, that would be called as experiment. Then we have sample space. Basically, sample space is what could be the possible outcomes. All the possible outcomes are called, if we put all the possible outcomes at one place, that will be called a sample space. For example, if we roll a die, then we know that it can be either 1, 2, 3, 4, 5 or 6. There cannot be any other outcome. There are only these 6 outcomes. So if we put them, the sample space for rolling a die would be this 1, 2, 3, 4, 5 and 6. There can be many other cases. For example, if you appear for a test and the test has 10 questions and each question has 1 mark and there is no negative marking. So the sample space will be 0 to 10. Either you get all correct or 1 correct, 2 correct, 3 correct and so on till 10 correct. So the sample space there will be 0 to 10. Basically, sample space is nothing but all the possible outcomes. Then we have an event. From that sample space, what if we put an event, what could be the possible outcome or what outcome we want? For example, if I roll a die and I say that the event should be an even number. So what could be our favorable outcomes? In a die, the favorable outcome will be 2, 4 and 6. These are the only 3 numbers which are even number. So in that case, the event will be even number. So whatever our favorable outcome is, what do we want? That would be called an event. Now we have 2 important terms and these are very important. Just understand, this is very related and it is easy to understand. First is mutually exclusive events. Basically 2 or more events which do not have anything common. For example, if we say that if we roll a die, if I name 2 events, first event is, it's a even number, and let's say there is another event 2, let's say this is an odd number. Now in this case, if you roll a die, a number will be 1, 2, 3, 4, 5, 6. For event 1, the possible outcomes will be 2, 4 and 6. For event 2, the possible outcomes will be 1, 3 and 5. Now in both cases, nothing is common and such kind of events are called mutually exclusive events. Both have nothing common, or basically we can say the 2 events that cannot appear at the same time. Either a number that will be the outcome on the die, either the number will be an even number or will be an odd number. It cannot be both. It is not possible for a specific number to be both. So whenever there are 2 events where nothing is common, that is called mutually exclusive events. Now, what is exhaustive events? Similar to this, there are exhaustive events which cover up all the sample space. Basically, the 2 events which cover all the possibilities. And for that also we can assume the same example. Die can have this sample space. The sample space can be this. Either it has to be 1 to 6. Now there is one event which is an even number, so it can be 2, 4 and 6. There is second event which is an odd number, which is 1, 3 and 5. Now if you can notice, these 2 events cover up all the possibilities of the sample space. And whenever there are events which cover up all the possibilities, those events are called exhaustive events. So if you notice that these 2 events are mutually exclusive as well as exhaustive events. They can't appear at the same time and they cover up all the possibilities of the sample space. I hope this would be clear. Let's just cover up the definition. So mutually exclusive events that cannot happen at the same time. If one event occurs, the other cannot occur. and exhaustive events which cover up all the possible outcomes of a sample space. At least one of them has to be has to appear. This was the important terms. Next we'll go to next slide. Then we have probability. Now if you notice, probability is nothing but it's about what could be the possible chances, or you are measuring what are the chances that an event can occur. For example, if you understand with a number line, let's say we have 0% chances here and 100% chances here. Now if you put anything in between this number line, and the event can be anything. Let's say the event is, what are the chances that the rain will be, there will be rain tomorrow. Let's say the chances are 60%. So you put a random number in between this number line. Either there can be no chances, or there can be 100% chances. There cannot be more than 100% chances. So whenever there is an event and you try to measure what could be the chances of that event occurring, that is called a probability. A measure of likelihood an event. What are the chances that an event can occur? How do we measure it? It is nothing but we trying to find the ratio of the favorable outcomes divided by the all possible outcomes. So in denominator we put what could be the all possible cases or all possible outcomes, or basically we put the sample space. What are the all possible outcomes that are there? And in numerator we put what are our favorable chances. How much chances we put on. Next point, it is very obvious, you know that the range for a probability is 0 to 1. 0 means the outcome cannot happen. If I say a probability is 0, it means it will not happen. For example, I say that I am rolling a die. What is the probability of getting a 7? We know that there is only 1 to 6. It cannot be 7. So when we know that for sure that the event cannot occur, the probability will be 0. On the other hand, if we know that an event will definitely occur, then the probability will be 100%, or 100% in another sense. We say the probability is 1. For example, again, if I roll a die and I say that the event will be the outcome will be an even number. Now we know that there are only 6 possible outcomes, that is 1, 2, 3, 4 and 5, 6, and all these numbers are natural numbers. So we know that whatever outcome will come, that will be a natural number. So probability of occurring and getting an even number on a die will be 1. So the range for probability is always 1. There is one more point here, that we know that if we sum up all the possible outcomes, the probability should be 1. It cannot be more than 1. It has to be exactly 1. For example, if we say that there is going to be a match between any two teams, either one of the team has to lose or they have to win. So probability of winning plus probability of losing, the sum has to be equal to 1. There cannot be any other outcome. So if we sum up the probability of all the possible outcomes, that has to be equal to 1. Next we have, now this is important. A lot of people, if we try to club up the probability, or if we try to club up the events, then we have to see the rule of OR and the rule of AND. In the next slide, we will study the rule of AND. In this slide, we will study the rule of OR. We have, I'm sorry guys, I was not checking the phone. So hello Arnav, hello Pramera, Creative Paradise, Arnav Jha. Hi, good evening. Yes, Pramera, you will get the test scores after the mock immediately. Yeah. Okay. So we'll have to see first, if we have the OR, it means that if I say that, if we take the small example, that probability of occurring, what is the probability of occurring an odd number or a prime number? Odd number or a prime number in a die. So if you notice that we have OR in between, either one has to take place. So now we'll see that the two events we are putting Are they two events mutually exclusive events, or they are not mutually exclusive events? Mutually exclusive, again we just discussed, it is nothing but if nothing have common in between. If they don't have common in between, then we simply add up the probability of those two events. For example, if I say probability of occurring an odd number or probability of occurring a multiple of 6. Now, if you notice that these two events are mutually exclusive events, these two the possible outcomes cannot have anything common. A number, if it is an odd number and 6 is an even number, any multiple of 6 will be an even number. And on the other hand, we are understanding the probability of an odd number. They both cannot appear at the same time. So whenever the events are mutually exclusive, they cannot happen at the same time. For that, whenever there is a OR case, we simply add up their probabilities. So in those cases, probability of odd number or multiple of 6. Multiple of 6. In that case, we simply add up those probabilities. Probability of odd number plus probability of multiple of 6. So this is one case when they are mutually exclusive. Second case, when they are not mutually exclusive, or if there is something common in between. Now if you imagine that, let's say I have these two circles. This has this part, this has this part, and this part is common. Now if you notice that I am taking the probability of occurring of these two events. So I am adding up this part plus I am adding up this part. Now if you notice that this common part has been added both times. So we have to remove that common part. And that is the whole concept of when the events are not mutually exclusive. For example, let's say what is the probability of occurring an even number or probability of multiple of 4. Now if you notice that, and the case is, the experiment is, if we roll a die, same is above case. Now if you notice that all the numbers which are multiple of 4 will definitely be an even number. So they have something in common. For example, if we try to understand what could be the possible cases here, the cases here will be 2, 4 and 6. What will be the possible case here? The case here will be 4, because in a die the only multiple of 4 is 2. So the only multiple of 4 is 4. Sorry. Now if you notice that they have something in common, they are not mutually exclusive. For that, what we do is we sum up their probabilities individually and then we subtract the probability of the outcome which is common. Why? Because that for the probability of that outcome, it has been added here as well as here. For example, for solving this question, what would be the probability that the event is an even number? There are 3 possible cases, 3 favorable cases. And what is the whole sample size? Sample space, sorry. The sample space is 1 to 6, which is 6 number. So the probability of getting an even number is 1 by 2. And the probability of getting a multiple of 4 is 1 by 6. So if we add up here 1 by 2 plus and this, then we have to subtract the probability of the common part. The common part in this 2 is 4 only. So we'll have to subtract the probability of this. That is 1 by 6. Again, we have to subtract 1 by 6. This will cancel out. So the probability will be 1 by 2 only. Why? Because if this is already a part of this, we do not need to consider this separately. The whole idea is, if the two events are mutually exclusive, simply add up their probabilities. If the two events are not mutually exclusive, then add them individually and then subtract the probability of the common part. That is the whole idea here. I hope this would be clear. Let me know in the chat if this is clear. Math magic. I think we have covered averages in one of the previous class. what I would suggest is go to Google, search Cracku IIMB UG playlist or videos. You will get the link, and we have uploaded all the videos there. Search there. If you find us, find the video of average. If you still face the issue, on the website you will have our helpline number. You can call us, and our team will help you. Okay, we'll move on now. So in the last slide we studied if there are if I want only one case out of multiple events I gave. Now if I give two or more events and I want the probability of all combined, then we have to generally do the product, because we are finding one probability and multiple probabilities for the same event, for clubbing the events. Now, for example, again let's take the example of die. Why we are taking the example of dice is because it's easy to understand, because it has limited outcomes. If I say the probability that the outcome, so the event has to be, let's say event has to be an even number and a multiple of 6. In this case I am using AND. It means I want both the events to be satisfied. Now again we have rule 1, that is if the two events are independent events. Now understand that what are independent events. You clearly can observe with the word only. Independent events are the events where the two events are not dependent on each other. For example, outcome of one, if I roll a die and if I toss a coin. In this case, I am doing two separate experiments which has nothing in common. They are not dependent on each other. In the first event, I am rolling a die. In the second event, I am tossing a coin. Let's say I'll say what is the probability that if I roll a die, the outcome has to be outcome has to be a prime number, and if I toss a coin, the outcome has to be a heads. Now the two events are different. They have nothing. They are not dependent on each other. In that case, simply what we do is we'll find their individual probabilities and we'll simply multiply. They are not dependent on each other, so we are not required to find any relation. We simply find their individual probabilities for two events separately and simply multiply them. But in another case, that is rule 2, if the events are dependent. Now what do I mean by dependent? It means one or the other event is dependent on previous event. For example, let's say that if I let's take another example of cards. Okay, we know that there are 52 cards. Now if I take out a king, and what is the probability? The second card I take would be of a hurt king. Now if you notice that in event 1, let's write down the events. Event 1, let's say I get a king out of 52 cards. For the students who might not understand what are cards and all, don't worry, we have one slide for this. We'll be covering all the different possible kinds of cards are there. It is important to understand because a lot of times questions are asked on cards, so you might have some basic understanding what kind of different cards are there. Out of 51 cards, event 1, if I take out a card, it's a king. Okay, now, and I don't replace it without replacement. Now event 2, taking out another card. This time it's another card. It can be any card. Let's say it's a jack. Now if you notice that the first card I am getting is a king. From 52 cards, I have taken out one card. For the second event, how many cards are left? 51 only, because I am taking without replacement. Without replacement means I have taken out a card, but I have not put it back. If I put it back, then the second event will be out of 52 events only. Then it will be an independent event. Both the events are individual. but what card I take first, and then there will be 51 cards remaining. The next event will be dependent on those 51 cards. It will not be dependent on 52 cards. So whenever there is a case where the cards are taken out without replacement, then if you notice that the second event will be based on what would have been the outcome of the first event, or how many cards are left, or any sort of. So whenever there are such events where these two events are dependent on each other, mostly in most of the cases the second event is dependent on the first event, but it is not always necessary. So in those cases, you have to use the second rule. What the second rule says that? Second rule says that for the probability A, which is the independent, if you notice that in both the events, one of the event will definitely be independent. Out on the second event will be based on that independent event. So for the independent event, you will simply find the probability. You multiply that on the second event, but again second event will be based on the will be dependent on the first event. So the probability for that event will also be based on the probability of the first event, and you calculate the probability based on what would have been the outcome of the first event, and then you multiply, you get the final outcome. In first one, you simply find individual probabilities and multiply. In second one, you first multiply, you find the independent events probability, and the second probability, it is depend on event 1, and you find the probability of that, and you simply multiply. We'll cover this kind of questions in today's class, and then you will understand much better. I hope this is mostly kind of theoretical. When you start applying, you will realize that okay, this event is dependent and this event is independent. Okay, I think we'll move on now. So these were the two rules for OR and AND. If you are asked OR, understand that if the events are mutually exclusive or non-mutually exclusive. And if it is based on AND, then understand that if the events are dependent or independent. If they are independent, simply multiply. If they are dependent, find the probability of the first event, which is independent, and then for the second probability based on based on the probability of the first event. Now, what is conditional probability? If you notice, it is nothing but it is independent probability. One event is the probability of calculating one event when another event has already happened. So conditional probability says that probability of an event given that another event has already happened. Now if you notice and if you understand, if I have a big sample space, and if I say that one of the event has already happened, so I need to find the probability based on that event which has already occurred. So it will reduce our sample size. For example, let's understand, I have a dice. I want to what are the sample space? 1, 2, 3, 4, 5 and 6. Now if I say that what is the probability of getting a prime number considering considering it is an odd number. Probability of an odd number considering the outcome is an prime number considering the outcome is an odd number. Now if you notice that in conditional probability, one of the event has already occurred. We have already known that the outcome is an odd number. So if one event has already happened, our sample size will reduce. From this, I will remove the other parts and I will reduce my sample size to small one, that is odd number one, that is 3, 1, 3 and 5. And from this sample space, I need to calculate the probability of prime number. What are the prime numbers here? 3 and 5 both are prime numbers, so 2 out of 3. Basically in conditional probability, what have happened? the event that has already occurred, you reduce the sample size to that, sample space to that, and find the probability based on that one. You remove the unnecessary or the unnecessary outcome which cannot occur based on the event has already occurred. Again, coming back to the same, the probability of an event considering one event has already occurred. The sample space is reduced, obviously. This is how we represent probability of getting an A considering B has already happened. So what is the probability? How do you calculate probability of getting B and then probability of getting which is common to A as well as B? Let's understand one more example here. We have a question. We have, okay, a family has 2 children. Okay, given that at least one child is a boy, what is the probability that both the children are boys? Now, if a family has 2 children, what could be the possibilities? The possibilities can be both are boys, both are girls, there is one boy, first boy and second girl, or there is first girl and second boy. These are the 4 possibilities only. Okay, this is our sample space. Now, one of the event has already occurred. What event has occurred? Given that at least one of them is a boy. So our new sample space, that is sample space dash, will be one of them has to be a boy. So we have this outcome possible. This outcome is not possible. Both cannot be girls when we know that one of them is a boy. At least one of them is a boy. So this cannot happen. This is possible. And this is also possible. And then we need to find the probability that what is the probability that both children are boys based on this outcome. So what is our favorable cases when both children are boys? That is only one case. Out of what are the all possible outcomes? All possible outcomes are 3. We did this question based on reduced sample space. Another one can be, if we solve it this way, what could be the probability of getting B? That is the event that has already occurred. If there are 3 children, what is the probability that at least one is a boy? At least one is a boy is 3 by 4. There can be boy, boy, girl, girl, boy, girl, and girl, boy. This could be the sample space. What is the probability of getting at least one boy? That is the probability of the event that has already occurred. If there is at least one boy, it can be this case, and this case. So there are 3 cases out of 4 cases. What is the probability that A as well as B also should be there? A, that is both the children are boys. This probability, and B is obviously should be there if at least one of the children is boy. What could be the possibility for that? Satisfying both the situations. There can be only one possibility, that is boy and boy, because that is something we are finding. Both are boy. There is only one possibility out of 4 possible cases. So the possibility for this is 1 by 4. If you cancel this, you will get the same answer, 1 by 3. So you can do it either way. You can either reduce your sample space or you can do it with the formula. Formula says that what is the probability of getting A considering B has already occurred. So you find the probability of B, the event that has already occurred, and in numerator you will have the probability of the number of outcomes which satisfy both, that is event A as well as event B. So this was about conditional probability. We have covered AND rule, OR rule, conditional probability. Next we have one important topic, that is cards. Now don't understand that we are doing it, we are asking you to play cards. Nothing is like that. Basically in probability questions, a lot of type of questions are based on cards. So we'll understand, okay, what kind of cards are there generally. There are basically 52 cards. Okay, all you need to understand is just the classification. Out of these 52, there are 26 red cards and 26 black cards. So we have this done. We have 26 red and 26 black. The cards which are red are equally divided as heart and diamonds. So there are 13 hearts and 13 diamonds. Similarly, the cards which are black are spades and club. So there are 13 spades and there are 13 clubs. A lot of you have difficulty in remembering, okay, what is what. And just remember the acronym HDSC. Try to remember it some way. Hearts, diamond, spades and clubs, red and black. Now, in each of 13 types, so this is, so these four are called suits. There are four suits: hearts, diamonds, spades and clubs. This is done. Then we have each of these 13 cards have their ranks. So we'll start with 1, 2, 3, 4 up till 10. These are called number cards. One is called ace. Then we have 11, 12, 13, which is nothing but jack, queen, and king. And this is same for all. So this is how we define the 13 ranks. And then there are basically, this has to be 3. Sorry. Or if you understand that, 12 face cards for each. For three face cards for each. These king, queen, and jack, these are called face cards. So there are 3 face cards here, 3 face cards here, 3 face cards here, 3 face cards here. So in total there are 12 face cards. That is jack, queen, and king. It can be of any of the suit. This is the major classification. 52, 26, 26, red and black. Remember, HDSC, heart, diamond, spades and clubs, and then there are 13 cards. 1 to 10 are numbered one. One is called ace, and then we have 3 other face cards: jack, queen, and king. So yeah, this was the major topics that we had to cover in probability. Now we'll move on to questions and we'll try to apply, okay, what are the concepts, how to apply the concepts of probability in actual cases. We have this question, first question, easy one. We'll do this. You have 90 seconds for this. Let's try. Yeah, from here it is 2 to 20. Basically, one is called ace only. I really suggest you guys to appear for this question. You can answer in chat. Yeah, nice. Good one from Era. Okay. It was an easy question. It says that when India and Australia play a test match, the probability of India winning the match is 1 by 5, while the Australia not winning the match is 1 by 4. Now, what is the probability of the match being drawn? Now, if you notice that, we studied that the probability of the sum of the probability of all possible outcomes has to be 1. So, what could be the probability? If you notice that probability of either India wins plus probability of Australia wins plus the third outcome can be probability of draw. The sum of these three has to be equal to 1. Now, we know that the probability of India winning is 1 by 5. So, probability of India winning is 1 by 5 plus the probability of Australia winning. Now if Australia is not winning is 1 by 4, the probability of Australia winning will be 1 minus 1 by 4, because either Australia wins or lose. So the probability of Australia winning will be 1 minus 1 by 4, that will be equal to 3 by 4. So the probability of Australia wins will be 3 by 4 plus the probability of draw. This has to be equal to 1. Now if you sum up this, we have the LCM has to be 20. 5 into 4 will be 20, so 4 plus 4 into 20 will be 4 into 5 will be 20, so 5 into 3 15 plus probability of draw. This will be equal to 1. If we sum up, this will be 19 by 20 plus the probability of getting draw will be 1. If we take this value to the other side, we get probability of draw will be 1 minus 19 by 20. When we take to the other side, the sign gets changed, so positive gets negative. If we take the LCM, 20 minus 19 divided by 20, or this will be equal to 1 by 20. So the probability of getting them as a draw will be 1 by 20, which is option A. All you need to understand here is the sum of the probability of all possible outcomes has to be equal to 1. Let's move on to the next question. Okay, this is also a good question. Let's solve this. Okay, this was also an easy question. It applies a concept of permutation and combinations, and that class is already done. So I hope that you would be able to do this. It says that a box contains 10 balls, each labeled with a unique number from 1 to 10. Okay, 10 balls numbered 1 to 10. Okay, 2 balls are drawn at random without replacement. This is important, without replacement. What is the probability that both balls have prime numbers on them? Now if you notice, just the formula of probability, that is probability of getting an event is favorable number of favorable outcomes divided by total number of outcomes. Now we need to find them individually. First, let's find out total number of outcomes. There are 10 balls, 10 different balls, and we want 2 balls from them, and they are numbered 1 to 10. So there can be multiple cases. There can be 1, 2, 1, 3, 1, 4, and so on. There can be so many cases. But in combinations, you have understood that whenever there are n number of things and you need to select R from that, we can find the number of cases in NCR ways. that is n factorial, r factorial, n minus r factorial. Here we have 10 things. So we have 10 things, 10 balls basically, and we need to select 2. So n is equal to 10 and r is equal to 2. Out of 10 things, I need to select 2 things. So this can be done in 10 3 2 ways. That is 10 factorial divided by 10 minus 2 factorial into 2 factorial. That will be equal to 10 factorial. 10 minus 2 is divided by 8 factorial into 2 factorial. If you solve it further, now 10 factorial is nothing but 1, 2, 3, 4, 5, 6 up till 10. So I can, if I open this, I can write this as 10 into 9 into 8 factorial divided by 8 factorial into 2 factorial. 8 factorial and 8 factorial will cancel out. Then we have 10 into 9 in the numerator, and denominator we have 2 factorial. 2 factorial is nothing but 2 only, because 2 factorial is 2 into 1. 2 into 1 is 2 only. If we cancel this, 2 into 5 times will be 10. So we have 5 into 9, which is 45. So in total there are 45 total number of outcomes in which I can select 2 balls. Now we'll find the favorable outcomes. I want favorable outcomes, that the 2 balls are prime number. Now if 2 balls are prime number, out of 1, from 1 to 10, how many numbers are prime number? So there are 2, there is 3, there is 5 and 7. So out of these possible prime numbers, how many pairs I can make of 2 prime numbers, because both the prime numbers has to be equal to 2. Again we can use permutation and combination, that is, there are, out of 4 numbers I need to select 2. So n will be 4, r will be 2. So I can write this as NCR, that is 4C2, that will be equal to 4 factorial divided by 4 minus 2 factorial into 2 factorial, that is 4 factorial divided by 2 factorial into 2 factorial. If we open up the 4 factorial, we have 4 into 3 into 2 factorial divided by 2 factorial into 2 factorial. 2 factorial, 2 factorial can cancel out. 4 into 3. 2 factorial is nothing but 2 only, as we just discussed. We can cancel this out and this will have 6. So there are total 6 possible pairs I can make out of these 4. What can be they? They can be 2, 3, 2, 5, 2, 7, 3, 5, 3, 7 and 5, 7. So favorable outcomes are 6 and total number of outcomes are 45. We put into the formula, we have 6 divided by 45. Always remember, we try to represent probability in the simplest form. So if we both are divisible by 3, we cancel out with 3. We have 3 into 2 will be 6 and 3 into 15 will be 45. So the probability of getting prime numbers out of this will be 2 divided by 15, which is option number B. It was slightly, if you know the permutation combination, it would have been easier for you. We'll do the next question now. Okay. Hi, all rounders. Yes, you can ask your doubt. Yeah, from Mera, very good. You had a good, you had a correct answer. Okay, this was again an easier question. It says that in bag A there are 3 red and 4 black balls. Okay, while in bag B there are 5 red and 6 black balls. Let's write down. So we have bag A. There are red and black balls. In bag A we have 3 red balls and 4 black balls. In bag B we have 5 red balls, 5 red balls and 6 black balls. Okay. Now it says that if one of the bags is randomly selected and a ball is drawn from it, what is the probability that it is a ball? It is a ball drawn is black. If you notice that we are saying that one of the bag has to be selected and the ball has to be a black ball. The bag can be either this or this. If you understood, we are going to use the concept of or, because the bag can be either of them. Let's solve if the bag is A. Now if bag A, what is the probability of selecting bag A? There are 2 bags and out of that I am selecting bag A. So the probability of selecting bag A will be 1 by 2 into what is the probability that it has to be a black ball. In bag A there are total how many balls? There are 7 balls. Out of 7 there are 4 black balls. So the probability of getting a black balls out of those 7 balls will be 4 by 7. This is the probability if the bag is A. Or in our case we add, if it is bag B, again out of 2 bags the probability of selecting bag B, out of 2 things I am selecting one thing, the probability will be 1 by 2 into I want a black ball. There are 11 balls in total in bag B. Out of this 6 balls are black. So probability of getting a black ball out of these 11 balls will be 6 by 11. This is for black bag B. All we need to do is solve this. We can cancel this out. This will be 2 by 7 plus. We can cancel this. This will be 3 plus 3 by 11. This simple fractional values. We take the LCM. 7 into 11 will be 77. So 11 into 2, 22. Plus 11 into 7 times will be 77. 7 into 3 will be 21. If we add up, this will be 43 by 77. We have nothing in common, so we cannot further divide this. So the answer has to be 43 by 77, which is option number A. Simple and easy question. We'll move on to next question. Let's check if any of you have any doubt. Please ask. Yes, Framera, correct one. Good one. Okay, this is the next question. Based on cards, remember the concept or remember also the classification. Okay. Now, I hope that you remember the classification. Okay. It says that from a deck of 52 playing cards, 2 cards are drawn at random. Okay. What is the probability that they contain at least one king? Now, we are taking out 2 cards and we want the probability of at least one king. Whenever you have such cases where it is asking at least something, then always try to break the solution into cases. Let's say there are only 2 cards and we are saying at least one king. So there can be case 1 where there is exactly one king, or there can be case 2 where there are exactly two king. These are the only 2 possible cases. In both cases, there is at least one king. Here we have exactly one king and another card will be other one. Here we have exactly 2 cards, exactly 2 kings. Let's solve this. What is the number of cases in which I can get one king and one another case? One another card. How many kings are there? We have remembered that in one suit of 13 cards, there is one king. And there are 4 suits: hearts, diamonds, spades and clubs. There are these 4 suits and each suit had one king. So in total there are 4 kings. So the one king can be of any 4 type. Into, now the second card I want in this case, because there is only one king. So other card has to be other than king. It can be any other card but other than king. We have 52 cards. Out of this, 4 are king. So how many cards are there which are non-king? There will be 52 minus 4. From this, I remove the king cards, which is 48. So the other card has to be any other card other than king. So these are the total number of possible pairs I can make where there is one king and the other card is any other king. We solve, we have 32, 192. Second, if I want exactly 2 kings, now we know that there are 4 kings. In those 4 cases, in those 4 kings, how many 2 kings of pair we can make? We did in the last question, that is, if there are n things and I want to select R, this can be done in NCR ways. So we have 4 kings. Out of this, we want to select 2 kings. This can be done in 4C 2 ways. That is 4 factorial divided by 4 minus 2 factorial into 2 factorial. This is nothing but 4 factorial divided by 2 factorial into 2 factorial. 4 factorial can be extended further or elaborated as 4 into 3 into 2 factorial divided by 2 factorial into 2 factorial. This can be cancelled out. 2 factorial is nothing but 2 only. 4 into 3 divided by 2. This will be 2 and this will be equal to 6. So when there is exactly one king, there are 192 cases. One king and other card can be any other. And when there are only exactly 2 kings, out of those 2 cards, there are 6 cases. So what are our favorable cases? We assume that there has to be at least one king. So if there is one king, 192, there is exactly 2 king, 6 cases. So favorable number of outcomes. That is 6 plus 192, that is equal to 198 are the total possible outcomes. Now what are the total number of outcomes? Now to calculate total number of outcomes, we know that there are in total 52 cards. Out of those 52 cards, I want to select 2 cards. So there are 52 cards and from that I want to select 2 cards. Again we will use permutations and combinations. Remember that it is going to be heavily applied in probability also, because there can be n number of cases, and to calculate that faster you should know permutation and combination. That is why we covered the permutation and combination concept first. If you have not watched that session, please go watch that. It will be helpful for you. So if there are n things, out of which I want to select R, I can represent that in NCR ways. That is equal to n factorial divided by R factorial and n minus R factorial. If we solve this here, we have 52 things, and from that I want to select two things. This is possible in 52 factorial divided by 52 factorial, 52 minus 2 factorial divided by 2 factorial. This is nothing but 52 factorial. 52 minus 2 will be 50 factorial into 2 factorial. If we expand this, 52 factorial is nothing but 52 into 51 into 50 factorial. 50 factorial and 2 factorial is nothing but 2 only. We can cancel this out. We can also divide this. This will be 26. So the total number of total number of outcomes will be 26 divided by 51. So probability at least one king. This will be equal to, in denominator we put total number of outcomes, that is 26 into 51. In numerator we put our favorable outcomes, that is 198. We know that this is multiple of 3 and this is also multiple of 3. So we can cancel this out. This will be 17 and this will be 3, 6 and 6. This can further cancel out. This will be 13 and this will be 33. So 33 divided by 13 into 17, that is 170, and 51, that is 33 divided by 221. This is the probability. The answer has to be 33 divided by 221, option B. It was a good question. Let's move on to next question. Let's solve this. From a good one, you had a correct answer. All around us, I'm not sure how you got 43 by 43 by 77. Please recheck and try to see, okay, where you made any mistake or where you lacked the concept. Let me know in doubts if you have any doubt, or you can ask your doubts in the chat. Okay. This was an slightly logical question. You might need to evaluate a few cases. It says that there are 12 people in a town. 12 of them are men. 22 people are there. Sorry, 12 are men and 10 are women. Okay. So we have 22, in which we have men 12, yeah, and women 10. Okay. Now, if 3 new people enter the town, what is the probability that men are not more than equal to men? Women are not more than men. Women should not be more than men. They can be either equal or less than, but should not be more. So, if 3 people are entering, what could be the cases? There can be case like there are 0 men and 3 women. There is one case there is 1 man and 2 women. There is one case where there are 2 men and 1 woman, or there can be one case where all 3 are men and 0 women. I mean, these are the only 4 cases. Now, in all 4 cases, what could be the number of men and women will be there after these 3 people enter into the town? So, if there are 0 men and 3 women, the number of men will become 12 only. There will not be any change, and the number of women will be 13. In second case, there will be 1 man will be added, so there will be 13 men, and 2 women will be added, so there will be 2 women. In third case, 2 men will be added, so there will be 14 men, and 1 woman will be added, so there will be 11 women. And in the last case, all the 3 men will be added, so there will be 15 men, and there will be 10 women only. Now we want the case where the women are not more than men. I mean, this is possible case because women are less than men. This is the case where women are less than men, and this is also the case where women are less than men. We don't want this case. Now we know that for any event, the sum of the probability of happening an event or not happening an event should be equal to 1. We want the probability that these 3 things can be there, but this is not possible. So if I find the probability of this case and subtract it from 1, I can get the probability of these one. Basically, probability of happening something and not happening something is equal to 1. If I want the probability of happening something, I can find this in 1 minus probability of not happening something. So if I find the probability of this case where all the 3 people are women, what would be the probability? All 3 are women. Now we are given that assume equal probability for being a male or a female. So for having a woman, for the first person, the probability of having a woman will be 1 by 2. Similarly, for the second person also, the probability of having 1 by women is 1 by 2. Similarly, for the third person also, the probability of having a woman will be 1 by 2. This will be equal to 1 by 8. So the probability where all the 3 are women is 1 by 8. And this is something we don't want, because if we have this, then the number of women will be more than men. We don't want that. So what we can do is we can remove them. If we remove this from the probability where women are not more than, let's write it clearly, probability of women not more than men. This can be solved as 1 minus probability of women are more than men. And we know that 1 minus, what is the probability that women are more than men? When there are all 3, all 3 people, additional people will be women, and this is equal to 1 by 8. If we solve this, this will be 8 minus 1 by 8, and this will be equal to 7 by 8. So this is a probability where we can say that the number of men will be more than or equal to women. It will not be less than. So the probability has to be option A. Now you could have solving this also, but it is time consuming to solve for 3 different cases, find their probability, rather than solving one case, finding the probability of one case and removing them, we will get the probability of the other cases. And this is how this is going to be an important formula. Probability of having something, probability of not having something should be equal to 1. You can apply this in multiple ways and save your time. I hope this would be clear. Let me see if there are any doubts. Yes, all rounder from my right was your answers are correct. Good one. We'll move on to next question. Okay, solve this. Okay. Now again, it is an interesting question because most of the times you are told that okay, the die is, and for many other events, the probability is like means they are equal. But in this case, we are told that the dice is biased. It says that a die has its faces numbered 1 to 6, and the dice is biased such that the faces with even numbers are twice as likely as the faces with odd numbers to show up on the top. Or basically, the probability of getting an even number on the top is twice than the probability of getting an odd number. So let's say probability of getting an odd number. Let's say the probability is 1 by x. We don't know the probability because it is a biased one. So the probability of getting an even number will be what? This will be twice of this, that is 2x, 2 divided by x. We are told that the dice is biased such that the faces with even numbers are twice as likely faces with the odd numbers to come up on the top. If they to come up on the top means the probability of the even number. Probability of the even number is twice as the probability of the odd number. Okay. Now we know that the sum of the probability of all possible cases is equal to 1. Now in dice, we know that a number can be either positive or a number can be either odd or a number can be either even. So the sum of these two possible cases, these two possible events will be equal to 1. There cannot be any other case. So we can say that the sum of all the possible odd numbers to come up and the probability of them and the probability of all the possible even numbers to come up has to be equal to 1. So there are three odd numbers. So the probability of getting all the three numbers on the dice will be 3 into 1 by x. Plus, similarly, there are three even numbers. So the probability of getting them on the dice will be 3 into 2 divided by x. This has to be equal to 1. Sum of the probability of all even odd numbers and all even numbers. If we solve, we have 3 by x plus this will be 6 by x. This will be equal to 1. We have the denominators common, so we can sum up directly. This will be equal to 1 or 9 will be equal to x. If we replace 9x, we have the probability of getting an odd number will be 1 by 9 and the probability of getting an even number will be 1 by 2 by 9, sorry, because the probability for even number is twice. Okay, now we are asked that if a die is rolled to randomly, what is the probability that the die is showing a 3? The probability for getting a 3 will be, because 3 is an odd number, the probability of getting an odd number will be equal to 1 by 9. So the answer has to be 1 by 9, option B. It was simple. All you need to remember that the dice was biased, so you need to make the cases for both the events, and you should know that the sum of the probability of all possible outcomes will be equal to 1. Let's move on to the next question. Okay. Yeah. Let's check if we have any doubt. Okay. Okay. It was slightly on a harder side, but logical question, good question. It says that Raghu tosses a coin 6 times. Okay, a toss, we know a coin we know that have two faces. It has either heads or it has either tails. So there are two possible outcomes. Okay, the probability that the number of times he gets heads will not be greater than the number of times he gets tail. So heads can be as much as equal to number of tails, but cannot be more. For example, let's say how many heads are there, how many tails are there. We know that they are tossed 6 times. Okay, so if we assume that both are equal, so there are 3 heads and 3 tails. Now it says that the number of times he gets heads, heads should not be greater than tails. Heads should not be greater than tails. So heads can be maximum equal to tails, or heads can be less than tails. It cannot be greater than tails. So when they are equal, it means there are 3 heads and 3 tails. And when their heads is less, it means what can be the other cases? It could be there are 2 heads and 4 tails. There can be 1 head and 5 tails, or there is 0 head and 6 tails. These are the 4 possible cases we have. Okay. Now we just find what are the total number of cases we can find. We know that in each case there are total 6 number of times the coin is tossed. We can find the probable number of cases for each case. Let's take case 1 where there are equal heads. So out of their 6 tosses, I want 3 heads. This can be done in 6 3C ways. We just discussed how you can calculate this. That is 6 factorial divided by 3 factorial into 3 factorial, or this is nothing but 6 factorial. We can elaborate 6 factorial, that is 6 into 5 into 4 into 3 factorial divided by 3 factorial into 3 factorial. This can cancel out. 6 into 5 into 4 divided by 3 factorial is nothing but 3 into 2 into 1, which is 6. So this can cancel out. This will be equal to 20. So there can be 20 cases where there are equal number of heads and equal number of tails. So there are 20 cases. Okay. Now case 2, where there are 2 heads out of 6. Case 2, I want 2 heads out of 6 number of times the coin is cost. So I want 6 C2 ways. Out of 6 I want 2 things. This again, if we solve, this will be 6 factorial divided by 6 minus 2 factorial into 2 factorial. This will be 6 factorial divided by 4 factorial into 2 factorial. 6 factorial we can open up, that will be 6 into 5 into 4 factorial divided by 4 factorial into 2 factorial. This can cancel out. 2 factorial is nothing but 2 only, so we can cancel this with 3. Here we get 3 into 5, that is 15. So the total number of cases here will be 15. Now let's find the number of cases for third case also, where out of 6 times the coin is cost, there is only 1 head. Case 3, there is only 1 head. Now this you can easily calculate. I am tossing 6 times. How many times I can get 1 head? In how many different cases? There can be one case where head was at the first position, another case where head was at the second position, another case where head was at the third position. This way head can come at 6 different positions. So this is possible in 6 ways, or you can also do it in this way. You will get the same answer. And then we have fourth case where there is 0 head. It means all the 6 are tails. In how many cases this is possible? I want 0 head. This is only possible when all the outcomes are tails and there is 0 head. This is only possible in one way. There is no other way I can represent this. So in total, how many total favorable cases are there? Total favorable cases. So we have first case where we can get heads and tails equally. This is possible in 20 ways. Then we have another case where there are 2 heads and 4 tails. This is possible in 15 ways. Then we have only 1 head out of 6 times it is tossed. This is possible in 6 ways. And then we have one case where there is no head. All the six outcomes are tails. So this is possible in one way. So the total number of outcomes will be 20, 35, 41, 42. So this is the total number of favorable cases. Now we need to calculate total number of possible outcomes. Total possible outcomes. Okay. So we know that first time if coin is cost, what can be the number of cases? It can be either heads or tails. So there are 2 possibilities. Similarly, for second time, again there are 2 possibilities. Similarly, for the third time also there are 2 possibilities. Similarly, there are 2 possibilities in the fourth case, 2 possibilities in the fifth case, and 2 possibilities in the sixth case. So this is the total number of possible cases I can make, possible number of different arrangements I can make. This is equal to 2 raised to 6, and that is equal to 64. 2 raised to 6 is 64. So in total there are 64 outcomes which are possible if I toss a coin, and out of this there are 42 times where heads are at most equal to tails but not more than that. So what is our probability? Probability will be heads at most equal to tails, or we can say hats is not greater than tails. That is 42 divided by 64. If we divide this will be 21 divided by 42. What is our answer? Okay, 21 divided by 42. Sorry, this is 32. My bad. This is 32. 64 divided by 2 will be 32. So our probability is 21 divided by 32, which is option number D. Let's move on to next question. This is going to be the last question of the day. Okay, let's try to solve this. Okay. I think that this was a difficult question, but we'll solve this. It says that a coin is tossed once and a die is rolled twice. If you can remember, these are independent events. A row, there is a coin and a die. Now it says that a person wins the game if he gets a head and at least one even number. He is rolling the die twice and he wants at least one even number. The possibility can be there is one even, one odd, or both even. So there are two cases. Okay. Find the probability that he wins the game. That in the first one he gets a head, and in the second one he gets at least one even number. Now if you notice, in such cases we always do the multiplication of both the events. Now for the event 1, which is getting a head, because for winning he needs a head. What is the probability of getting a head? What is the probability of getting a head when we toss a coin? So probability of getting a head is, out of two events, it is possible in one way. So it is either heads or tails. Getting a head is 1 by 2. Now we need to find the probability at least one even number. And if we get this, we will simply multiply them. Okay. So basically we need to find in how many cases we can get at least one even number. So again we will make two cases. There is one case where there is one even plus one odd number. Okay. So the even number is, let's say we have one even number, one odd number. This is possible in 2, 4, 6. This is possible in 2, 1, 2 3 2 5. Similarly 4 1 4 3 4 5, and we have 6 1 6 3 and 6 5. Also I can reverse them, so 2 1 can also be called 1 2. Then also we have 1 even and 1 odd. So in total all these numbers can be reversed also. Since there are 9 numbers and we can also reverse them, so there are 18 numbers we can make, or 18 possible outcomes we can make, where there is 1 even and 1 odd on the two different roles we have made. So there are 18 possible outcomes. Case 2, when both the outcomes are odd, sorry, both the outcomes are even. Both even. This is possible in 2 4 2 6 2 and 2 also. Then we have 4 2 4 6 4 4. Then we have 6 2 6 4 6 6. These are the possible cases we can make. We cannot reverse them because 4 2 and 2 4 already taken. So there are 9 cases here. So in total we have total 9 plus 18, 27 cases which are our favorable cases. Favorable cases are 27. Out of them, and we need to calculate the total number of cases. Total cases. So when we roll the die, what are the number of possible outcomes in the first roll? There are 6 numbers, so any of them can occur. Into similarly in the second roll also there are 6 possible outcomes. Anyone can occur. So in total there are 6 into 6, 36 total outcomes. So the probability for getting an even, at least one even number is, at least one even number is 27 is our favorable outcomes divided by 36 our total number of outcomes, which is, if we cancel, this will be 3 by 4. So the probability of getting at least one even number is 3 by 4. We can put it here. So he wants one head and at least one even number. Both are independent events, so we can multiply 1 by 2 into 3 by 4. This will be equal to 3 by 8. So the probability of getting him, he wins is 3 by 8, which is option number C. So this was the class that we have done on probability. We understood the basic concept, and we did some questions based on multiple scenarios. I would suggest you guys to go through the session. If you are not able to understand, you can put it in the comments. Our team will help you and clear your doubts. If you have any other doubt, you can also call and email us. You can get the same on our website. You can find the complete playlist videos on our website. Just go to Google and search Cracku IIM Bangalore UG playlist or videos. You will get it. Next we have basic things. Again, we can't emphasize a lot on, we can't, this is something which is very, very important. Mocks are going to be very important if you want to really ace the exam. Because when you sit for 2 hours, you will be habitual for that. And it is going to be very important to get yourself prepared for the actual exam. And also considering not much time is left, I would highly suggest you guys to go to Cracku IIM Bangalore UG mock test. They are free, they are very good. A lot of people are taking. Just go to Google, search, you will get it. Just search Cracku IIM Bangalore UG mock test. The first link will be of our mocks, and you can attempt that. All these mocks are free. So you can also help your friends by suggesting our mocks if you like them. Also similarly, we are doing the streams daily on YouTube. If you like the videos, please like it, share among your friends. It will be helpful for both of us. Next we have last, if there is something, if you are wondering where you can get all the important notifications and all the important stuff at the one place, join the WhatsApp group. In the disclaimer, you'll get the link to join the WhatsApp group. You can join, and we'll be putting all the important updates there. With that, I'll wish you all good luck. Good night, guys. Bye.